Hello and welcome to another episode of Study Session 4, AP Physics 1. In today's video, we will be covering electric forces and fields. It's one of those chapters where whenever you first hear about it, you might think it's a little weird or maybe even a little bit challenging, but it's really not that bad once you get some practice in. It's really not bad at all. It's just a bit unintuitive, I guess. Even there, it's pretty intuitive. It's just it's not something you're extremely familiar with in your day-to-day basis. So let's start with some basics, I guess. So one key concept of this chapter is the electric force, which I'm gonna just write force sub E equals KQ1 Q2 over R squared. So instantly you can notice it's an inverse square law because we're in, okay, so let me first define everything that's in the numerator. So R is obviously the radius. And Q1 and Q2 are the values of the two charges in coulombs. And then your K value has a value of 9 times 10 to the ninth, okay? So basically, that's how you solve for your electric force, and then this value will be in newtons. If you notice, this is an inverse square law, inverse square relationship to where the electric force is proportional to the inverse square of radius, and this is actually very similar to the gravitational force equation because Fg equals big G m1 m2 over r squared as well. But if you remember, big G is a lot smaller than 9 times 10 to the negative ninth. So that's something you will have to notice in comparing these two forces, especially on really small scales. The electric force is typically stronger than the gravitational force. Okay, well, let's get into some practice problems. So the first question says, if the distance between two positive point charges is tripled, then the strength of the electrostatic repulsion between them will decrease by a factor of, okay, so we've got two charges. We'll just call this plus Q, and then we'll call this one plus Q. And these are a distance 3d apart. And they were originally a distance d apart, so that's also plus Q plus Q. So if we use our equation, Fe equals K Q1 Q2 over R squared, we get that the original electric force equals KQ, I'm just going to say that those are both the same, so KQ squared over R squared. And then after it's moved to a distance of 3D, it's going to be KQ, not KG, KQ squared over 3R quantity squared, which is equal to KQ squared over 9R squared. And as we can see, it decreased by a factor of 9. That was a really bad box. 9 because it's 1/9 of the original value. You could factor out a 1/9 from that equation to get this equation. So yeah, let's clear that off and get to the next practice problem. Okay, this one says two 1 kilogram spheres each carry a charge of magnitude 1 coulomb. So I'm just going to draw sphere 1, sphere 2, 1c, 1c. And a coulomb is a unit of charge, by the way. How does the electric force strength, or the strength of the electric force between the two spheres compared to the strength of the gravitational force between them? And the correct answer is the electric force is greater than the gravitational force, and that's because the K value is so much bigger than the G value. K equals 9 times 10 to the ninth, and then the big G, I don't exactly have it memorized, but I can go find it real quick. Just let me, it gives it to you on your equation sheet, so you really don't have to memorize it for AP Physics 1, but it is 6.67 times 10 to the negative 11th. As we can see, K is far greater than G, thus the gravitational force will be far greater than the electrostatic force will be far greater than the gravitational force. Next practice problem. The figure below shows 3-point charges, all positive. If the net electric force in the center charge is 0, what is the value of y over x? Okay, so we've got one charge here, and this is plus 2q. Another charge here, which is just plus q. And another charge here, which is plus 3q. And we know that this distance here is x, and this distance here is y. So we know that the net force is 0 because the electric force is 0. So the repulsive force from this to that, so I'm just going to say A, B, C, and that's just labeling. So the repulsive force from charge A to charge B must equal the repulsive force from charge B to charge C, because the A to B repulsive force is going to be to the right direction, whereas the B to C repulsive force is going to be in the left direction. So what we can do is we can basically just set these equal to each other and solve. So if we use our equation, K 2Q times plus Q, and we're trying to find Y over X, okay, times Q over X squared equals K 3Q, because we got our 3Q from there, times Q, which is from there, over Y squared. So we can cancel out the K's by dividing by K. We can cancel out these Q's by dividing by Q. And we can cancel out this Q with that Q. So we want Y over X, so we're going to multiply across by Y, and then we're going to divide by 2. I'm going to divide by 2 over here, and we get Y squared over X squared equals 3 over 2. Thus, if we take the square root of both sides, we get Y over X equals the square root of 3 over 2. There we go, and on to the next practice problem. Okay, let's do this one. Okay, a sphere of charge plus Q is fixed in a position. A smaller sphere of charge plus Q, so our first charge is plus Q, and the second charge is plus little q, is placed near the larger sphere and is released from rest. The small sphere will move away from the large sphere with... Okay, so we've got to envision this. We've got our large sphere, and then we've got our tiny sphere. And they're both carrying the same charge, so we know that it's going to be a repulsive force. So it's going to be moving away. All right, so all these say it's going to be moving away. And now it wants to know if the velocity and acceleration are both going to be increasing and decreasing. So let's recall back to our force equals mass times acceleration equation. So the acceleration is dependent on the force. And if we think about it, our force is going to be the electrostatic force, which is equal to KQ1 Q2 over R squared. And now K, Q1, and Q2, those values aren't going to be changing, but what is going to be changing is the value of R. And if we think about this, as R increases, what's going to happen to our force? Our force is going to decrease. Well, if our force decreases and the mass stays constant, then our acceleration has to decrease. So the acceleration is decreasing. And if we think about it, the acceleration is always going to be in that same direction as the force. So the acceleration direction isn't changing, and since it's accelerating, that means the velocity is increasing. So the correct answer would be as it moves away, the velocity increases, however the acceleration decreases. On to the next problem. Okay. A charge of negative 3Q is transferred to, a charge of negative 3Q, okay, so negative 3Q, is transferred to a solid metal sphere of radius R. So solid metal sphere of radius R. Where will this excess charge reside? Okay, so this, I know whenever I took AP Physics 1 last year, this really wasn't a big thing. It wasn't really tested, but I know if you're planning on taking AP Physics 2 or AP Physics C&M like I am this year, it is tested. So it's a hollow metal sphere. So if we draw this, this is all metal, this is all metal, this is all metal. Okay, so let's think about this logically. So we've got a charge, and what do we know about metals? Well, metals are conductors. And basically what happens if you charge a metal sphere, all the charges group towards the edge. So those negative 3 will all be on the outer edge of this metal surface. So it will be negative 3Q on the outer edge of the surface. I don't really have a good, there's no really mathematical explanation that I can give right here to say why that is. It's just because it is a conductor, and they will want to, all the charges want to be as far away as they can from each other. So they're not going to reside on these inner radiuses or inner radii, because then you would have more charges per unit surface area or whatnot. So that's basically it. Well, hopefully you guys enjoyed. If you have any more questions, be sure to ask it on my website, studysession.org, and I will do my best to answer them. Hopefully you guys enjoyed this video. Hopefully you learned how to do this, and I will see you guys in the next video.